Did you hear me?
Yes.
Thank you. Just double check a bit. I just opened two devices. One for checking a chat box. The other one is on the checking the volume. Let me put it this way. Is it better? Because it seems no more echo. Is it? Is it better?
Yes.
Good. Better. Yep. Nice. So while we're waiting, now I would like to tell you where we'll be going is on 2A. Now, could you please take out the textbook 2A? Textbook 2A. Now, what I mean is this one. I would like to share with you here. Now, for your easy reference, it's not the one. It's on this one. Okay. Acid and alkaline. Chapter 14. Now, take a look on that. Take a look on that. And page 2. Now, read the pages, and now we will start it right away. Now, this is the page. Please take reference to it. When shall we have the next? Now, all right, while we are waiting, could you please take the textbook 2A? And if you want to take reference to the ebook, you may also click on the Google Classroom and get the PDF version. Have you all done that? Now, just wait for 2 minutes, start over the lesson. Now, as I said before, you may take reference to this. Okay, we will start over the lesson right away. Okay, have you all got that page? So we come to book 2A, acids and alkalis. Now, acids, they are, today because time is quite limited, we just cover some of the essentials when you talk about acids. For a while, for time, we would leave it later. Now, please take a look on the book, textbook 2A, unit 14. I would like to check the attendance first of all. Chen Zhenhin, not here. Lưu Hiên gì yes, we have got Wang Zihian, are you here? Wang Zihian? No. Good. Sorry, hey. Trong lòng tin trong ngoại nào con từ lập lập chọn học khởi lượng của trong lấy gặp yêu là danh thầu chân chân trong真熱豬加熱，甚至謙增無顯。OK。Okay, all of you are here, so we will start over the lesson right now. Okay, now welcome all of you on Zoom. Now today we would like to have a topic on acid and alkaline, right? Somebody may have heard of it in form 2, isn't it, right? So could you please say it out or rewrite the chat box your understanding of acid and alkalis? Before I proceed, I would like to try to see if I need to add something more information about the old knowledge, or maybe you want to get some new knowledge, right? And how far you can go, and I would like to add something more to it. What do you think? Brainstorming, tell me. What do you know about acid and alkalis? Yes, acid and alkalis equals neutralization, and so it is a chemical combination of acids and alkali. Acids and alkali, so they will form what? What is the product? This reaction is neutralization, right? So what is the product? They'll form salt and what?
Water.
Yep, salt and water as the only product. That's it too. It is one of them. What else? You may say aloud about the individual or items, just like acid. What do you know about acid? What do you know about alkalis? Just this. Covalent compound that release hydrogen ion when dissolved in water, they are acid. Yeah. Some definitions about acid. So you talk about covalent compound that you I see the word release here. So we will use something more technical term while you talk about this topic when dissolved in water. Now we will use the term ionized. Is that okay? This one we'll use the word ionized. So what is mean by ionized is that this one is indeed a molecule. Okay, the acid is indeed a molecule form. So once it dissolves in water, they would change its form to form ions. So the process, what we call it, is ionization. So you'll know it later. Yes, that's right. What else? What else? What else that you know about acid? Yes, you want to say something? Yes. To your understanding, just free fall.
Acid.
Sorry.
Acid contains hydrogen ion.
Oh, acid contains hydrogen ion. How about alkali?
Hydroxide ion.
Oh, acid contains hydrogen ion, while alkali, they would contain hydroxide ion. Somebody say so, agree? But later on, my question is, for the chemical which contains hydrogen ion, it must be acid, and the solution containing hydroxide, it must be alkaline. Am I correct? Now, in other words, if I say that acid inside would have hydroxide ion, is it wrong? And alkali, I can also find hydrogen ions. Am I wrong? Now, that is very, very interesting. So, my question is, right, do they have these inside that tube? So, this is what we'd like to have a coverage of that. What is the uses of acid? Now, you may, any more points that you want to add? Fair enough. Now, if not, now take a look on that axis. Axis can be commonly found at home, right? For those who are naturally occurring substances. So you may find it as here in fruits and vegetables. So we see that tomatoes, orange, lemon. So you may have citric acid, 檸檬酸, oxalic acid, 草酸. How about yogurt? We have got lactic acid, 乳酸. Vinegar, we will call this as ethanoic acid, 醋酸, or we will call it as 乙酸. Or you use the word 乙甲乙丙, okay? Which means we have got 2 carbon, okay? The acid. So you may have got, they are quite naturally occurring. So collectively, we've got this 1, 2, 3, 4. Therefore, it is commonly found in our daily life as in the fruits or in the milk product or in the fermentation of alcohol or sugar. So we collectively will call it organic acids. In the past, people would think that those chemicals can only be found in living organisms. But now, of course, nowadays you find it not correct. Because for organic acids, nowadays we would have some technology to produce even from inorganic, even from other non-living, okay, substances. Okay, so I would like to talk to you one by one later. So, organic acid, it is commonly found in, as I said before, fruits, vegetables, etc. Right? So you may find it as organic acid. While you may find these two, vinegar and yogurt, as a fermentation product. Fermentation product. Okay, so you may find these as well. And how about these two? Now, these two, it is not an organic acid. Okay, it is something inorganic. Okay, so the first one that you may heard of that very often, it is carbonic acid found in soft drink. So carbonic acid, H2CO3. So indeed, it is not an organic acid. Okay, it is it can be found naturally. Where? It can be found naturally. In where? Okay.
Hi.
Yes, it can be found naturally. Yeah. In where? Carbonic acid.
I don't know. Maybe.
You don't know.
Limestone.
Limestone. Limestone, we have
What?
got carbonic acid, correct?
In the blood?
In the blood. Yes, carbonic acid is found in the blood because of the respiration. The carbon dioxide will back dissolve in the bloodstream and go back to the lungs for gaseous exchange. Yes, correct. And of course, in rainwater, you can also have got carbonic acid. Why? Because in the atmosphere, we have got carbon dioxide. Okay, it reacts with water. Okay, in rainwater to form carbonic acid. So that's why rainwater, we usually say it as a slightly acidic. Okay, so it is what we know it is carbonic acid. Of course, in Coca-Cola, there will be more. It is made by pressuring the carbon dioxide inside the solution to form some fizzy feeling. Okay, so the people who enjoy soft drinks, you can get what I mean. How about the last one? Is on toilet bowl cleanser. Toilet bowl cleanser. So nowadays, together with vinegar, we will use it, especially these days. Why? In cleaning, right? Before Chinese New Year, we have got a tradition, right, among Chinese that we need to clean the home. Okay, have you ever tried to use vinegar to clean something at home? Our vinegar is not just cooking. It's not pickling fruits. Okay, yes, you can, but also you can use to clean some kitchenware or maybe some even dealing with blockage of drainage pipe. Have you ever tried to use vinegar to help clear the blockage in the drainage pipe? Do you know it? Of course, it will not do it by its own. Yes, here, it will not add this by its own. It will get mixed with soda powder. It is a what we call it as baking soda. Baking soda get mixed with vinegar, and it will clean the drainage pipe. In case the drainage pipe is blocked by, for example, food debris, oil, etc., somebody will try to use baking soda mixed with vinegar. Of course, if it is really blocked by oil, using vinegar will not help so much. Okay, why? There's no reaction between the vinegar and oil. But for baking soda, it will help a bit. It will help a bit, okay, because it will slowly dissolve the oil into somewhat which can be flushed away by water. How about this? Toilet bowl cleanser. So you know it. Of course, it is used to clean the toilet bowl. Okay. So it contains phosphoric acid. So what is the use of phosphoric acid? Can you see here? You will see some words here. Can you see that? Removes what? Take a look. Rust, lime scale, and hard water stains. So what is that? Rust, I know it. It is hydrated iron 3 oxide. Just remember, how about lime scale? Lime scale, what is that? What's the chemical inside? It's in form of calcium carbonate. How about this? Hot water stains. It is also in form of calcium carbonate or other water insoluble substances. Okay, so this is what you know about the working action of the boilable enzyme. So wait a minute, Mr. Chin, how come I would specifically use this chemical to clean the toilet bowl? And what happens to the toilet bowl? Now, indeed, we have got a, do you know what is the flushing water? Do you know where does the flushing water come from? You know it? Is it from fresh water or seawater? Do you know it?
Fresh water?
Seawater. Seawater. Fresh water. Which one? You don't
Fresh
know?
water.
Fresh water. How somebody would think that it's fresh water, isn't it?
Seawater.
Seawater. Now most of the time nowadays in Hong Kong, it depends on different places actually. For most of the buildings in Hong Kong, we would use seawater as a flushing water. Of course, there may be some exceptions. So for example, some villages, region, we may heard of some flushing water using fresh water. Okay, but most of the time we use seawater. So what happened to the seawater? Have you ever been to the toilet, male's toilet? We have got a urinals, right? So you may have while you're going to do your business, and you may find some solid here. Okay, and maybe some solid just left behind after some water has been flushed off here. So what is that? It is what we call it as lime scale. It's of lime scale. But why we have got lime scale is because seawater is a hard water. So the question comes, what is meant by hard water? 硬水. Hard water means a water containing calcium and magnesium ion in certain concentration. Okay, so we have got it another comparative term. We call that salt water. Now, in drinking water in Hong Kong, our drinking water is salt water. It has less amounts of calcium ion and magnesium ion. But once you want to talk about spring water, 礦泉水 or underground water, most of the time you will have rich calcium ion and magnesium ion. So you know that these two belong to group 2. Now group 2 compound, some of them is not so water soluble. For example, in the form of carbonate. Okay, so and it will slowly form on the places where the water flow is rather slow. Okay, so that's why we need to clean the toilet bowl frequently using some acid. That indeed, the acid they will react with the metal oxide, carbonate to form something water soluble. So that's why you will use those bowl cleanser for help. So what is the chemical? It is phosphoric acid, 磷酸, and which will help dissolve those water insoluble substances to water soluble substances, such that you can flush to the drainage pipe easily. Okay, is that clear? So be observant while you help your mom cleaning at home. Be wise to choose the chemical they want. Okay, so you may use this one, but somebody who want to have a less damage to the drainage pipe, somebody would love to use the vinegar instead. Of course, you may use some commercial drainage cleaner, but this is a very corrosive alkaline, a concentrated alkaline. Have you ever heard of caustic soda? Caustic. So it is alkaline. So we would use those chemicals to help clear the blockage of the drainage pipe. Any questions? So we come to this, just having a daily life items. So we will have the characteristics of dilute acid. So how about in our school lab? The school lab, they are commonly, that three acids, they are commonly found. We will call that as HCl, H2SO4, and HNO3. Hydrochloric acid, 鹽酸 or 氫氯酸, while sulfuric acid, 硫酸, nitric acid, 硝酸. So that three acids they are commonly found in our school lab. Of course, there may be more. That acid, we call it mineral acid. 礦物酸 is because they derive from minerals. They derive from minerals. For example, now for sodium chloride, it comes from what? It comes from the mineral we call that sodium chloride. Okay, HCl comes from NaCl solution. And while NaCl solution comes from seawater, so it's done by what? Electrolysis of saturated sodium chloride. So you may find the three product H2, Cl2, and NaOH. Right? While we have got that two, they merge together, they react, then they will form HCl gas, and I dissolve it in water, and they will form it as NaClAq. Okay? So HClAq. So this is what we call it hydrochloric acid, together with an alkaline. Okay, so we will call this one a mineral acid because it's come from mineral. But once I have got HCl, I can also use this to produce the salt. Why? Now, for example, if you have got the baking soda powder, for example, I would react with an acid to form NaCl again, CO2, and H2O. So you may find this one, the salt has also been regenerated if I use a sodium carbonate, right, to help. So it will also produce a salt. So very special about this dilute acid. Now remember, if you talk about dilute acid, we'll use the hexa warning label irritant. Irritant is for dilute acid only. Okay. But if you want to talk about the concentrated acids, so you would use another hexa warning. We will use the word corrosive. Okay. For Form 2, while we study acids, we do not tell it so specific so clearly, right? About when to use irritant, when to use corrosive. At that moment, could you please mark it down? For dilute acids, we'll usually use a hexa warning label irritant, while the concentrated acids will commonly use the word corrosive to describe the action on the of the acid on your skin. Okay, do you understand? Of course, there may be something, some more hexa warning labels when you talk about the other acids of concept, for example, concentrated sulfur acid, concentrated nitric acid, we use oxidizing as well. So we will talk about it later. Any questions? Now, besides, so what is the following? You talk about it as a property of acid. Properties of acid, of course, for organic acid you can taste. Okay, we have got a sour taste, but of course some other acids cannot be tasted. and so they would have some common property. For example, good conductor of electricity. They react with reactive metal. They react with bases. What is that? Bases. What is that? And react with metal carbonates and hydrogen carbonates. So you are going to watch a video shortly about this. Okay, so please wait for a while to get to know our video where you talk about acids. Sorry to say that we cannot have a chance of doing the experiments here. I take a look. Let me see, because something I should give you share the sound.
Cubic centimeters of dilute hydrochloric acid into each of 3 test tubes. Add 2 drops of litmus solution.
So I would like to do that again. But please let me know if you can listen to it.
In this experiment, you are going to investigate the properties of dilute hydrochloric acid.
Do you hear?
Pour 4 cubic centimeters of dilute hydrochloric acid into each of 3 test tubes. Add 2 drops of litmus solution, methyl orange and phenolphthalein into each test tube separately. Record your observations.
Okay. Wait a minute. Mr. Chin, you just tell the 3 very strange chemicals. What are they? Liquid solution, methyl orange, and phenolphthalein. What is that? What are they? We collectively call it as. What are these? What is the use of these 3? Alkaline indicator. Okay, we will call that an acid alkaline indicator. Please continue watching the video. So they were active quite differently.
Litmus solution in dilute hydrochloric acid appears as pink. Methyl orange in dilute hydrochloric acid appears as red. Phenolphthalein in dilute hydrochloric acid appears as colourless. Clean a piece of magnesium ribbon by using a sandpaper. Put the cleaned magnesium ribbon into a test tube containing 4 cubic centimeters of dilute hydrochloric acid. Trap any gas given off by putting an inverted stopper over the mouth of the tube. Use a burning splint to test the gas given off. A pop sound can be heard, which indicates that the gas given off is hydrogen. Put 1 spatula measure of sodium carbonate in a test tube. Add 4 cubic centimeters of dilute hydrochloric acid. Quickly stopper the tube using a stopper fitted with a bent delivery tube. Pass any gas given off through lime water. The lime water turns milky, which indicates that the gas given off is carbon dioxide. Put 1 spatula measure of sodium hydrogen carbonate in a test tube. Add 4 cubic centimeters of dilute hydrochloric acid. Quickly stopper the tube using a stopper fitted with a bent delivery tube. Pass any gas given off through lime water. The lime water turns milky, which indicates that the gas given off is carbon dioxide. Add a small amount of magnesium hydroxide into a test tube containing 4 cubic centimeters of dilute hydrochloric acid. Use a glass rod to stir the mixture. Magnesium hydroxide dissolves in dilute hydrochloric acid, forming a colorless solution. Add a small amount of copper 2 oxide into a test tube containing 4 cubic centimeters of dilute hydrochloric acid. Use a glass rod to stir the mixture. Copper 2 oxide dissolves in dilute hydrochloric acid, forming a blue solution. Place 30 cubic centimeters of dilute hydrochloric acid in a beaker. Set up the circuit. The light bulb glows, which means dilute hydrochloric acid can conduct electricity.
So you may just put out some of the reaction of the acid. So I'd like to go back to the our book. Now you take a look, quite a lot of information has been covered, right? Can you see that? Let me see. Do you find the screen here?
No, still just the videos.
Yes, that's a video, and I would like to share it once again. Yes. Let me see. Now I'd like to show you this one. Is that is it the one? Yeah. Yes, this is the ball. Can you see that? Now, so we would will overview on these topic, right? The conductivity electricity, reaction with the reactive metals, reaction with base or hydroxide, alkaline, we call it alkaline, the reaction of methyl carbonate and methyl hydrogen carbonate. We would like to show you these properties using hydrochloric acid and dilute sulfuric acid as a whole. So you may have heard of so many different items, right? You may find it rather confusing. Don't worry, we would like to talk about it one by one. The first one we'll talk about is the electrical conductivity. So whether or not it can conduct electricity. So acids and alkalis, they are both can conduct electricity well. Okay, just like the electrolyte. Okay, so indeed, HCl is also an electrolyte. But could you please underline two important words to account for the high electrical conductivity of the acid? No matter it's dilute HCl, dilute H2SO4, we still have these particles which will help conduct electricity. Can you tell me what that is? Two words. Two words. Very important two words. Could you please underline that? Two words.
Mobile ions.
Yep, good. Mobile ions. Could you please underline the term? Mobile ion are very important items. Mobile ion. So for HCl, the mobile ion can be found is H plus and chloride ion. While for sulfuric acid, we will have hydrogen ion and sulfate ion as the major particles which will cause the conduction of electricity. Of course, it is in the fluid like the particles inside, they are freely moving. We call them mobile, and it will help conduct electricity. Now, by attracting towards the electric field of opposite charge. Any questions so far? Now, easy, right? So how about let's go. Reaction with reactive metals. Now, so remember the term reactive metals. So it is caused by the definition. They will both dilute HCl and dilute sulfuric acid can react with a metal above hydrogen in the metal reactivity series. So what are they? Can you tell me what are those metals? You may see it at potassium, sodium, calcium, magnesium. How about next one? Aluminium, zinc, iron, tin, lead. Okay, and then hydrogen, and then later on. So we just stop at his. Remember, these two, we can never attempt this when I react with acid because the explosive reaction that will occur. Because that two chemicals, they are already very reactive. Do not get mixed with it with acid. I don't need to mention because I know it once I put in water, it's very dangerous already. So never put in acid. So the reaction that will cause an salt and hydrogen as a product. So please remember this general equation. And for dilute nitric acid, it is not the our scope. It's because of a slightly oxidizing property. So we usually, you talk about nitric acid, we will use the word very dilute. Now, if you want to talk about the common property of acid, is dilute hydrochloric acid, dilute sulfuric acid, and very dilute nitric acid. That three, they would have the similar chemical property. But if you want to talk about it as dilute nitric acid, now this is another thing because it is quite oxidizing. So we will call that mildly oxidizing. So the chemical property is quite different from other dilute acids, just like HCl and H2SO4. So remember, we would be careful when using the terms dilute, very dilute, okay? Whenever you talk about dilute nitric acid, it's different from very dilute nitric acid because the chemistry is a little bit different. Now, you go back to this, just take a look on HCl and H2SO4. Now, we focus on the word equation, chemical equation instead. Now, could you please underline how to talk about this word salt? How can a salt be made? How can salt be made? So you may see this is the salt form. Where can we find the component of the salt? Of course, you may find it as cations, and anion part of cations. For cations part, it comes from the what? The metal. Can you see that? For anion part, where does it come from? Yes, it is the anion of the acid. So they merge together to form the salt. For example, magnesium from the metal to form the chloride ion with the dilute hydrochloric acid to form magnesium chloride. While iron react with dilute sulfuric acid, the sulfate ion found inside the acid to form iron 2 sulfate. Is that clear? So leaving behind is, what is that? The leaving behind is hydrogen ion, and they will form hydrogen gas. Could you please label it using 2 different colors, right? So what is that? The other one is hydrogen ion to form hydrogen gas. Can you see that? It's another thing. It's another thing. Now remember, this one, it is still hydrogen ion, but not H2. Okay, it's hydrogen ion, but why is it 2? That 2 refers to what? It is in mole ratio 2 to 1. Okay, so I will mark it as H2SO4. When you compare with HCl, right, it's just 1 to 1 mole ratio. So you need not write as 2 after H. Now this H2SO4, the H2 is different from this one, H2. Is that clear? Now while this one, it is just a molecule with 2 hydrogen atoms combined together by covalent bond. While on the left hand side, the reactant, the acid itself, inside we have got hydrogen ions, okay, not hydrogen molecules. Is that clear? Now, how about the unreactive metal? Just like copper, mercury, silver, gold, platinum, they would not react with those acids. Is that clear? That's so we come to the first part. Any questions so far? So how would you test the what in common is that no matter what combination of the metal with the acid, as long as is within our range, they will react together to form salts and hydrogen gas. Hydrogen gas is a common product, but it's a matter of the no sound. Now take a look. I try to no sound. Somebody said no sound. Anyone who can tell me whether or not you can hear?
I can hear.
I
Yeah?
can hear.
Yes, because I have got.
Here.
Yep, I have got. I did not put the mute button, right? It's still there, right? Okay. So you better check it. Oh, okay. Oh, that may be the problem of internet system, right? So the hydrogen, is it? Okay. So as I said before, the second chemical property that I would like to mention is about the reaction with reactive metals. And once react to form salt and water, hydrogen. Number 3, reaction with bases, 鹽基. Okay, 鹽基. Okay, 鹽基. So what is that? You will see the word Chinese word, you may find it very interesting. What is that? Oh, it seems like a raw materials of making salt, isn't it? So we call that Chinese word called 鹽基. So indeed, that is the definition of the base. It is a substance that reacts with acid to form salt and water only. Now underline the term only. So for this reaction, it will cause this, we call that neutralization. No matter you will call it as a base or alkaline. Now, wait a minute, base and alkaline. So what is the difference? The base is just a bigger circle, while the alkaline is a smaller circle. Now, what is meant by that? All alkalines are said to be base, but not all bases are said to be alkaline. The difference is that alkaline, they are a very special chemical. In this, it is water soluble as well. Not just react with acid to form salt and water only, but we will call that a type of water soluble bases. water-soluble bases. So you can give some examples of that. For example, NaOH, it is dissolved in water, but for bases, if you talk about copper 2 oxide, it is not. Can you get my point? So this is what we call it as a base and alkaline. Then there are some, they are quite similar, but if you want to talk about the concept, it's a little bit different in terms of the solubility. Alkaline is water soluble, while base, it can be water soluble or it can be water insoluble. Can you please understand? So what are the common chemicals which talk it as a base? Now you take a look. Usually we talk about oxide and hydroxide of metal. We have with acid to form salt and water, and that is the item. So I would like to share with you on these two cases. The first one, the copper 2 oxide react with acid. In your video, we talk about copper 2 oxide react with what? React with acid HCl, right? To form copper 2 chloride. The solution is blue, and together with this, it's also blue. Copper 2 sulfate is also blue. Why? It contains blue copper 2 ion. So this is the reason. Okay, so indeed what happens to it is that we are going to have a chemical reaction just like last time. I would like to highlight this time with you. This time is copper 2 sulfate, is copper sulfate. Can you see that? It seems like merging the two chemicals like this way to form copper 2 sulfate. So what is left behind? We've got oxide and hydrogen ion, and you form water. Can you get my point? Now, believe it or not, now you take a look on another example on using zinc hydroxide, we react with HCl. You do the same tricks. The salt that I can form is zinc chloride. It is the combination of zinc and chloride ion, each from part of the base, while part from the acid. Can you see that? So zinc chloride. So what is left behind is hydroxide ion. Now remember, the 2 refers to the mole ratio between zinc ions and hydroxide ion being 1 to 2. How about the other one? Is hydrogen ion to form what? Is form water. You find it interesting, isn't it, right? Can you generalize how you can write down the chemical equation for this? Better, right? So you may find simply I will use the oxide form or hydroxide form. We react with the hydrogen ion of acid to form water. Can you get my point? Leaving behind is for the metal with the N ion part. You merge together to form a salt. Is that clear? Okay, so the way to classify is by this. We come to the third, here comes fourth chemical property. We will call it as a reaction with metal carbonates and hydrogen carbonates. So this is the reaction. Now remember, because of the carbon dioxide form, we would not call this type of a reaction neutralization. Maybe you may try out the experiment in primary school, having baking soda react with vinegar, right? So in that, it is not neutralization. Why? Because besides salt and water is formed, I also have got carbon dioxide. So there is one more extra product, which will make the difference between this one and the neutralization. Can you see that? It's just salt and water. Now, just like the one the video, and you may find two examples which will help. The first one is calcium chloride. The formation of calcium chloride. Salt is from calcium carbonate. We react with chloride. Now, can you see that? Similarly, sodium sulfate can be found as a sodium hydrogen carbonate react with sulfuric acid. So underline just like last time. Now we are doing something similar. So what is left behind? It is carbonate react with acid, right? To form what? CO2 and H2O. Can you see that? Now, similarly, you use hydrogen carbonate, react with acid, and what will they form? Again, okay, CO2 and H2O. Once once they react together, they will form colorless gas bubbles. So we will call it is carbon dioxide. We will call this phenomenon effervescence. So whenever you talk about this, you talk about the fizzy tablet, just like Hong Kong C, right? So indeed, it is also a type of a chemical reaction, it's quite similar. The reaction between the carbonate and acid to form carbon dioxide. So fizzy is a description of the same, okay, fizzy tablet, and that is the reason. Do you understand? Now, if you want to test for the presence of CO2, I use lime water. Okay, so the lime water test, it is the key. So you may find the lime water, they will initially turn milky for little amount of calcium of carbon dioxide. But if you have got excess carbon dioxide bubble into it, the milky solution turns colorless again. So this is what you have to memorize it hard. Okay, please put a star here. It is used to tell you what happens when you have got the lime water react with carbon dioxide to form something milky. Can you see that? Milky is because of some white water insoluble salt, white PPT of calcium carbonate. While calcium carbonate will still back dissolve inside the solution when I have got enough carbon dioxide, and I've got excess carbon dioxide. And why? Because it will form a water soluble. Can you see that? It turns the water soluble calcium hydrogen carbonate, which is dissolved in water. So the natural environment, in the natural environment, you have also got this phenomenon while you talk about erosion of limestone. Can you please recall your memory about this? Erosion of limestone. Do you still remember that? Okay. Now, one more point. Now, could you please mark your label setup to do this action? Right? How can you do this in practice? Could you please draw the label setup in the spaces provided? For example, here. Out. Well, next. Spend some time on it. So you have got lime water here. While inside, we have got metal carbonate or hydrogen carbonate react with dilute acids. Okay, so we have got that. Remember, you have to do the two actions. First of all, stopper in here. Why? It will help confine and direct the flow of CO2 once formed, and they will go through here, they will pass through here, and they will meet the lime water. Okay. Second, it's on here, no stopper, open system. Do not put a stopper here, right? If you have got both stopper here, what will happen?
Explosion.
Yep, somebody will say the explosion if you have got quite a high pressure. But practically, before explosion, I need to tell you what will happen is that lime water will not turn milky. Do you know why? If I put both stopper on both sides, lime water will not turn milky. Do you know why?
The concentration of carbon dioxide is so high that they, in fact, turned into hydrogen carbonates.
Or somebody will say that carbon dioxide, because of the high concentration, it will rapidly turn to hydrogen carbonate. Now, a wise guess, but they is not something related to chemistry. It's something about
the air pressure.
Yes, the pressure inside the both system is still the same. Can you get my point? So you need to talk about physics. Actually, in order to bubble the CO2 into lime water, first of all, you would experience here having a higher pressure, higher gas pressure, which will help. By doing so, we will have a directional flow of gas to the one which have a lower pressure. But indeed, it is just atmospheric pressure. Oh, so it is of a lower pressure. Okay, can you get my point? So in case just like having a bottle of champagne, I just shake it. Okay, so what will happen? They will have a pressure build up. Once I stop the cork will pop up so easily. So that's why what is the reason? It's because of the imbalance of the pressure inside and outside. So similarly, so the gas pressure here must be higher than that bubble in the lime water, such that they can bubble. So what will happen if I got both stopper here? It seems like a pressure cooker, right? The whole system is still of the same pressure. So the CO2, once it is formed, it will not be still going to the lime water. So of course, the lime water will not turn milky. Can you get my point? Only, but if you have got quite a large amount of carbonate, quite a large amount of acid, they may cause some splashing of the water because the stopper will just pop up. Okay, it depends on the amount actually. But remember, one is should be stopped, one should be open. Okay, is that clear? So we come to this a very slight conclusion of today's lecture, and you may find the three chemical properties between the dilute HCl and dilute H2SO4 with the reactive metal, with the base, with the metal carbonate, and with the metal hydrogen carbonate. Okay, and also we have got what? We have got some more properties of acid, just like being electrically conductive. Do you still remember that one? Electrically conductive, as well as the action. I forgot. Action on acid alkaline indicator. Do you still remember those names? Could you please mark it down? Do you still remember the name of the acid alkaline indicator? First one is forgotten. The word is L. The second one is BM. The third one is P.
Phenolphthalein.
Yes, phenolphthalein is the third one. How to spell the word? Now you have to spell the word correctly. So what is the color when I have got an acid onto phenolphthalein? It becomes, what's the color?
Colorless.
Yeah, colorless. Colorless. How about the other one? How about the action of litmus? Just like treat it as litmus paper, right? So you would use the word litmus solution, right? While the color is the same, if I use the litmus paper being red. How about the third one? We will use the word methyl orange or methyl orange. Gặp cây trắng is another third type of acid-base indicator. So the color of it is red. Okay. So you will know it one by one later. Again, you will revisit that 3 space indicator later. Any questions so far? Now, this is what I would like to draw attention. Do not get mixed with some bathroom cleanser. And do not get mixed with, for example, chlorine bleach with toilet bowl cleanser. Do you know why? Can you see some important items? Toxic chlorine gas. In the past, while you talk about SARS period, about 18 years ago, people would have myths. You talk about a vinegar can kill bacteria, okay? Chlorine bleach can also kill bacteria. In order to make a combined effect, okay, you get mixed of the 2. Of course, before you realize that the germs have also been killed, you will be also. Do you know why? Because of the accumulation of chlorine gas inside home. Remember. Okay, the household chlorine bleach, please do not get mixed with the other household chemicals, especially acid. All of you, please mark it down. Chlorine bleach, acid to form chlorine gas, which is toxic. Never, never do such. Is that clear? Now we come to the recap today by doing some class practice on page 8. Take a look on that. Now, could you please do it right now for question 1? State the products for each of the following reactions involving dilute hydrochloric and write the chemical equations. The first one, iron react with dilute HCl. I would like to invite somebody to have a try on that. Lê Minh Trấn. Could you please have a try on A1? Could you please tell me the product? Products.
The product is iron chloride.
Iron chloride. What is the charge of iron?
2+.
2+. So we will call that iron.
Iron 2
Iron 2 iron.
Yes. So then what is the name of the salt? Iron 2 chloride. What else?
and hydrogen.
Yes, hydrogen gas. So you may have got iron 2 chloride, iron hydrochloric acid to form hydrogen. So the equations, could you please write down the chemical equations together? Iron reacts with HCl to form iron 2 chloride and hydrogen gas. So this is the equation. So check your understanding on the formation of salts. You just remember iron, wrong color, iron 2 chloride. Can you see that? And then leaving behind is for this hydrogen ion to form hydrogen gas. It's not the end. Remember to do one important item. What is that? Balance the equation. Please remember to put a 2 here to balance the equation. Is that clear? How about number 2? Lime water react with dilute hydrochloric acid. What are the products? Hoàng Tránh Thông. lime water react with dilute HCl. So what are the products?
Calcium chloride
Yep, calcium chloride. And
carbon dioxide.
carbon dioxide. Agree? Now, in order to check your answer, you better write down the chemical formula of lime water. What is the chemical formula of lime water? Just one.
CaOH2.
Yep, calcium hydroxide, AQ. And hydrochloric acid is still HCl, AQ. So what will be the form? Now, just like the one above, right? You use this to highlight calcium, chlorine, chloride ion to form what? That is the salt, calcium chloride. And leaving behind was that? Hydroxide, ion, and then what? Hydrogen ion. So what will be formed? Hydroxide ion, hydrogen ion.
Water.
So what? Yes, just water. Do you have any carbon dioxide? The answer is no. This is because of the reactant. There is no carbon. Can you see that? There is no carbon. Now, this is not carbon. It's collectively, it is chloride. That C is not carbon. Okay? So we have missed out something. What is that? Is this equation correct? You need to do something.
Balance.
Yep, balance the equation. Can I have the mole ratio for that 4? What are the 4 numbers from left to right?
1, 2, 1, 2.
Yep, 1, 2, 1, 2. 2 HCl, 2 H2O. Okay, can you manage? Do you guys manage? How about the third one? Then Parker. Hello.
Oh, wait a second.
It doesn't matter. Maybe we will find it inconvenient. Could you please type it into your chat box? Magnesium carbonate react with dilute HCl. For those who have got a pen, you can also draw it on screen. I don't know whether or not I allowed to access it. This should be fine. You can draw. Let me see. Yep. I see. The answer: magnesium chloride. We have to form carbon dioxide in water. Nice. Okay, magnesium chloride. So the chemical equation. The chemical equation MgCO3 solid. So how will you know that is physical state? Now you have to memorize the solubility rule. Most of the carbonate is water soluble, except group 1, except ammonium carbonate. Okay, so remember, whenever you talk about carbonate, besides except those cases, it's group 2, right? so it's not soluble in water. How about HCl? I do the same thing to form MgCl2aq. So you may have this one, magnesium chloride, and leaving behind is on carbonate reactive acid to form what? Carbon dioxide and water. Now we miss out one thing again, balance equation. Yep. So what is how to balance it?
1 2 1 1 1.
Yep, it's 2 here. 2 HCl, 1 MgCl2, 1 CO2, 1 H2O, and it has been balanced. Any questions? So once I change the different metal salt, different metal oxide, different metal carbonate, or even different acid, here comes the way to solve the problem. How would you come up with the answer? And my tricks is to give you some hints about the salt form, and the leaving behind, you have to figure it by yourself on the product. Now, I would love to leave you as an exercise to do question 2 by yourself at home, and we would like to check the answer in the next lesson. Before you leave, could you please tell me your level of understanding before you leave? Five. Yep. Now some of you find it nice, right? Have a nice start, isn't it? Now it seems that you are seeking some patterns easily, huh? Any more questions so far? Now, if not, I would just like to stop here, and goodbye, Chem 2 students. Bye-bye.
Bye-bye.
Bye.
Bye. Goodbye.
Bye-bye.
Bye.
Bye. Bye.
Bye-bye. Bye-bye.
Bye. Bye. Bye.
Goodbye.
Bye.
Bye. See you in the quiz. Bye-bye.
Bye. Bye.